Okay, so with piecewise and step functions, you have different equations all taking place on the same graph, and here you have what's called a domain restriction. So we have the equation, and then only part of it that actually stays on the graph. So one of the ways to do this is to look at what your boundary points are. And I made a mistake. Did I? No, this is okay. It's okay. Okay, so my first boundary point is going to be 2. So what I'm going to do is make a vertical line where x equals 2. I'm just going to do that real lightly. My next boundary point is going to be x equals 4. And I'm going to do that real lightly at 4. So basically what's going to happen is for my graphs, I'm going to have one graph taking up this part, another one for this part, and another one for this part. So if I have x minus 3 squared, what shape is that going to be? The parabola, and what's my vertex of that parabola going to be? Yeah, 3, 0. So my normal parabola, if it was just x minus 3 squared and I was not concerned about a domain restriction, would have a vertex of 3, 0. It would go out 1 and up 1 in both directions, out 1 and up 3, and then out 1 and up 5. So rather than, I'll go ahead and do it. So if I have this parabola, and I'm doing this in pencil, I'm only keeping one chunk of it. So I'm either going to keep this part in the middle, or this part here. My domain restriction is that x is less than or equal to 2. So which part am I going to keep? The left, middle, or right? The left, because that's where x is less than or equal to 2. I'm going to erase the rest of this. The other thing I need to pay attention to is what kind of dot I have right here. Why does that matter? Whether it's included or not. This one's going to be a solid dot. Very good. Solid for the or equal to, or open circle for not or equal to. And I'm going to go ahead and darken this because that's the part I'm going to keep, and it's easier if it's more obvious. The next part of my graph is y equals x. What type of graph is that? Linear. Diagonal going straight through the middle. And if I were being responsible, I would use a straight edge, but yeah, use a straight edge. So real lightly, I'm going to go y equals x. So that's just going to be up 1 and over 1 in both directions. And am I keeping the left, middle, or right? The middle. And what type of circles am I going to have? Open circles. So I'm going to have an open circle here, where you can't see where I'm writing. Oh, I hate this one here. Okay. So an open circle here, and an open circle here. I'm going to darken the middle part, and then I'm going to erase the rest. I'm sorry this is not showing terribly well because of the glare on this. Give it a second to readjust. Let me see if that's any better. Nope, that's not much better, although the glare isn't there. Hang on. Okay, so I'm going to leave the light off for the rest of this one because you can see the open and closed circle part better. And then the very last one, 2x minus 8, is going to be another line. I'm going to start at negative 8, go up 2 and over 1, and then what part of this graph am I going to keep? Left, middle, or right? Right. So I'm actually only going to do the right part. And then that's going to be, again, because we're back to, or equal to, greater than or equal to 4, that part's going to be darkened. So a couple of hints on this. If you do it this way with the vertical lines and you have your 3 vertical chunks, you're never going to have more than one part of a graph in any particular chunk. You're not going to have any vertical overlap anywhere on a piecewise function. You may have some gaps, but you're not going to overlap anywhere. Any questions on the piecewise? So that was AA 1-9. For the ones that are sitting here, this is the standard that's being tested, and this is a worksheet. I know it's a little confusing. I apologize for that. A step function is just the same as a piecewise function, except you don't have strange different graphs. You're just going to have flat horizontal graphs because part of your graph is just a number. So for your boundaries on this one, what are your boundaries going to be on this particular one? -4 and 0. So on your on the step function, if you're looking at y equals -5, what kind of graph? What's that graph going to look like? Flat horizontal line at -5. So -5. Am I going to have an open circle or closed circle here? Open circle. And is my graph going to go to the left or to the right?
Right.
What does that say? That says x is less than -4. Remember, it opens to the bigger one, so it's going to go to the left. All right, so my middle one here, y equals -1 from -4 up to 0. So I'm going to go to where y equals -1. And my line is going to be from here to here. What kind of dots am I going to have on the end? Closed, filled in. So this is the difference between a step function and a piecewise function. A step function is going to look like steps, flat lines. No overlapping as well, though. And then the last one is at 6, where x is, what does this say? X is greater than 0. So I'm going to go up to where y equals 6. Make an open or a closed circle? Open. So something you should note on all of these, if I have a point on the same boundary point, one has to be opened and the other has to be closed. You can't have 2 closed circles on that same boundary. What? Oh, I did. Thank you. I put that on 5, not 6. That should be up 1, my apologies. Okay, so any questions on step or piecewise? All right. You don't have to draw these boundary lines in. I didn't teach it that way the first time, but for some people that can be really helpful. If you want to do that, then go ahead and do that. That's up to you.